Hey there. Today I'll introduce you to PydanticAI, which is one of the simplest Python AI agent frameworks, and it was designed to make it less painful to build production-grade applications using Gen AI. So this was built by the same team behind Pydantic, which is the data validation library behind lots of Python frameworks and libraries like FastAPI, even the OpenAI SDK, Anthropic SDK, LangChain, and much more. And it's model agnostic by design, so it supports pretty much all of the language models that you might want to use. Even the new DeepSeek and Mistral APIs are supported. And in my opinion, it's one of the simplest AI agent frameworks out there because it uses decorators to define the tools and assign them to the specific agents. And it's also very simple to get a multi-agent system going. So in this video, I'll cover creating a simple OpenAI agent. I'll also show you how to create a DeepSeek agent and also any other agent that uses the OpenAI format of API calls. I'll show you how we can do synchronous and streamed responses. I'll show you how we can format the output using Pydantic models to make sure it always replies in a structured format to using APIs and other systems. I'll show you how to define and use tools and also how we can do dependency injection to create more complex tools there. And we will also use these same tools to create a multi-agent system so an agent can delegate to other agents using the tools that we define. So enough introduction, let's get right into it. So let's install Pydantic AI. It's as simple as pip install Pydantic AI. But we can also use the Slim version to install only the integrations with the models we want. So we can do like OpenAI, Anthropic here and install just those, but I want the full package. So I'm just going to go. I'll also do pip install python.env so we can load environment variables from a .env file. And I'll open this folder in windsurf. So here let's create a new Python file, main.py. And here let's first set up our credentials with OpenAI. Okay, so from .env, we can import load.env and then add that function call here. This will load all of the content of this .env file and add them as environment variables. So we have OpenAI API key here and DeepSeek API key. You, of course, will have to create your .env file with your API keys, but this name here, OpenAI API key, is actually the default for Pydantic AI. So if we import agent from Pydantic AI, we can create a new agent here. We can just instantiate the agent class that we just imported. And the first parameter will be the model. So the structure is just like you're seeing here. It's first the name of the company and then a column and the name of the model itself. So OpenAI column GPT-4o will be GPT-4o. Okay, simple enough. So to prompt this model, we can do something like result equals agent.runSync and then print result.data. RunSync will wait for the LLM to finish giving its output synchronously and then return the data. So let's ask something like, what's the latitude and longitude of Tokyo, Japan? So let's save this and execute it, see what it returns to us. If we do python main.py, see the latitude and longitude of Tokyo, and then it gives the approximate latitude and longitude here. This is from OpenAI. You can see we didn't have to set the API key manually here. But if you want to use a different name for the variable, or for instance, if we're using DeepSeek, I'll show you how you can customize that as well. So besides agent, let's import from Pydantic AI.models.openai, import OpenAI model. And then here, when we create our agent, instead of typing in the string of the model name, we can instantiate a new OpenAI model. And then the first parameter will be the actual model name. Since we are using the OpenAI model class, we don't need to pass in the OpenAI prefix. And this is actually a way for us to call DeepSeek or any other API that uses the OpenAI format. So we can, for instance, set the model here to DeepSeek Reasoner, but then we will need to customize the base URL. So it's actually api.deepseek.com, the base URL. And then the API key would be os.get.env, and then the name of the environment variable that we're using. And then, of course, we will need to import OS as well for it to work. So this way we created an agent, customizing the base URL, API key, and model. But I'll go back to the simple agent that we created before, since I'll be using GPT-4o Mini for this tutorial. So here we can also pass a system prompt. So for instance, be as concise as possible, reply with one sentence. So this will limit the output to be as short as possible. Let's see. Okay, almost the same, just a word less, but it was already short from the start. So if we want to stream the responses, we could use a sync.io to do that. And that needs to be done inside an async function. So we can do async def main, and then everything inside this needs to be asynchronous as well. So async with agent.run stream, and then we can ask it a question. So let's say, tell me about Tokyo, Japan. Let's actually change our system prompt to make it be actually as verbose as possible. Let's say reply with a child text. And here we're getting with agent run stream as result, and then async for message in result.stream text. We're printing that message. So now let's install async.io. So pip install async.io. And here we can do async.io.run main, which is our streaming method, right? So let's do python main.py. Oops, I forgot to import async.io there. So import async.io. Then we can run it. And you can see now that our message gets streamed, but every token that we received, it prints the entire message from the beginning until the latest token. This is useful if we're like updating a div in a web page every time we get a new message chunk. But since we're doing this in the terminal, we can actually do delta equals true, and this will make it just print one chunk at a time without appending the entire conversation every time. And Python by default breaks the line every time we print, so we can do also end empty string and then flush equals string. So this will make it print in the exact format that we have received from the LLM. Yeah, so this is how you would stream responses using Pydantic AI. But right now it's running just two prompts, the system prompt and then the user prompt. Let's make it so it's actually an interactive conversation that we can keep asking questions to it and then increasing the context with all of the messages that we have exchanged so that it remembers what we were talking about and can execute more complex tasks and interactions. So let's create an infinite loop here while true, and then current message equals input, and then if current message is quit, let's break this loop. Otherwise, let's try getting the result of run sync, but passing our current message so that we can keep prompting the AI with multiple queries. So I can ask, for instance, when did the USD declare its independence? And then it responded, but it doesn't have the context of the past question. So if I say, what did I just ask you? It won't know. You asked me to respond as concisely because it only knows the system prompt, right? It doesn't remember these other messages. So let's actually add another variable here. Let's do message history. Let's set it to an empty array and let's pass it as another parameter to agent.runSync. So at the start, it will be empty, but after every interaction, we can do message history equals result.all messages. So this will get all of the messages both from the user and from the agent. So it will know what we asked and what it replied back and append all of this to the message history array here. So it will remember everything. If the conversation gets really long, this can get overwhelming to the LLM and actually consume a lot of tokens for you. So what I recommend you to do is set it to new messages. So it will only have the context of the newest messages, and after some time it will forget the older ones, just so it has some context of the conversation, but isn't overwhelmed with excessive info, right? So if we do this and try running it again, we can ask the same thing. When did the USA declare its independence? Then if we ask, what did I ask you so far? It will remember the context of that question that we made. So, okay, we have a chat application. It's not really an agent, right? We need to empower it to use tools that a normal LLM wouldn't be able to execute otherwise. So maybe fetching some information from an API or something like that. There is an API called OpenMeteor that gives some real-time weather information for free. So let's integrate with that for an example of how to create a tool. Let's import requests here, and then let's create a new function to call, let's call get weather info. Then we need a latitude, and it's good to type the parameters of all tools that we're going to create because this helps the LLM know what format to pass the information to this method. So the OpenMeteor URL is This one, we have slash forecast and latitude and longitude as parameters. We're passing what came here from the parameters of the method itself. And then we're just doing a get request and returning the response here. Very simple stuff. And it will return the temperature and the weather code for that specific latitude and longitude. So to add this as a tool to our agent, what we need to do is use the decorator called agent.tool. We actually can use either tool plain or tool to create tools. The difference between tool plain and tool is that just tool will require you to pass in the execution context, actually the run context. This is a way for us to do dependency injection for more complex functions that have some dependency that can change in real time. An example of that would be some user information, the current authenticated user, or actually a more realistic example is if you had a credential manager class and you need your tools, all of your tools to use this credential manager to do the requests and integrations that you have in your agents. And then you could rely on dependency injection to pass this class into the tools instead of actually sending your API keys in a system prompt that would be shared with OpenAI and rely on the LLM to actually fill in those parameters for you. So dependency injection would be the correct way of doing that. Since this tool doesn't require any authentication or anything like that, I'll just use tool plain to make it simpler for us. And this is pretty much it. Now our agent already can use this get weather info, and just by the name of the function, it will infer whether it should use this tool or not. So let's add some debug code here. Let's say print getting weather info for latitude and longitude, so we know when this function was called. And then let's interact with our agent again. Let's say what's the temperature in Tokyo right now. So it will know to use that get weather info too, and it provided the latitude and longitude for Tokyo that it already knew. But then it enhanced its response with whatever that tool replied to us. It gave us that the temperature is 8 degrees Celsius. So you can see the power and how quickly we can create agents and tools using this framework, right? So let me give you that example of passing some dependency here. For that, we need to import the run context as well. So let's create a fake credential manager class here. So class credential manager. Let's define then a get credentials method and just return some mock data here. So then we can create an instance of this credential manager. And here, when we're creating the agent, we can actually pass in the dependency type, deps type equals credential manager. So it knows to expect that this is a dependency for this agent, and this should be passed whenever we are running it or executing any interaction with it. So then in our agent.runSync call, we need to pass in deps equals creds manager. So now we're fulfilling this dependency that we defined here when we created the agent. And now we can use these dependencies inside the tools by changing this to tool instead of tool plain. And then here we can pass the entire run context as a parameter. So CTX. We can also type this, passing the run context that we imported and credentials manager. So now inside the method, we have access to our credential manager instance. So we can access it by ctx.deps. This will be all of the dependencies that we pass in here. This can be like an array with all of the manager classes and useful stuff that you need for your agent to run. So let's run this again. And if we say, what's the weather like in France now? Then it will have access to the credentials we injected using the credential manager class. So this is how you would handle dependency injection. All right, we don't actually need this credential manager here. This was just for an example. Let's change this back to plain, remove the context here and the credentials down there. So another thing we can also do is type the responses. So maybe we needed to return in a very specific format, maybe to use in an API. Maybe you're building a FastAPI to interact with your agent, and you needed to return in a specific JSON format. Since this was created by the Pydantic team, we can do from Pydantic import base model. Then we can define a result type. This will be just a Pydantic model for the response, and then we can format it however we want. But you have to remember that always when we call a tool, the parameters will be inferred by the LLM. And also when we ask it to format in a specific format, all of the values here will be inferred by the LLM. It's very important that we give very clear and understandable names to these parameters. So temperature is a good example of the information we need to get from the API, but we could even add something like fun fact about location, and let's make this a string. And then in our agent, we can also define a result type. and passing our Pydantic model here. Actually, I forgot to delete this dependency type. We don't need that anymore. If we run this again, we can ask, what's the temperature in Tokyo? You can see it returned the temperature and a fun fact about the location like we asked it to. And the good thing about Pydantic models is that we can serialize them into JSON. So we can do model dump JSON. Then we can pass indent to indent the response and make it more readable. So now if we ask the same question, you can see replies in a JSON model with our information here. Okay, last but not least, I'll show you how we can create a multi-agent system using all of these foundations that we've shown so far. So first I'll need to copy our agent definition here. Let's paste it below here. Let's call it main agent instead. And then here in result, let's say result equals main agent dot run sync. Let's add some comments to separate the agents. Okay, let's copy this and let's create now a weather agent. Let's call this weather result type. And then here we can set the response of our agent to weather result type. Let's call them weather agent as well. So it's very clear. And now our tool definition, we need to pass in the name of our agent, like the name of our variable that contains our agent here in the decorator. So it's now called weather agent. So we need to do weather agent.toPlane. And PydanticAI will automatically know that this is a tool that's available to this agent specifically. So I'll keep the same instructions here. Let's create yet another agent. Let's call them math agent. Let's just copy the weather agent here. Let's rename to math agent. I don't need a result type on this one. And let's change the system prompt for this math agent here. So just said, you're a math genius capable of solving complex equations and explaining to the user as if they are a kid. So we have these two agents, weather agent and math agent. Each agent is capable of using its own tools and they have their own capacities. So now in the main agent, we need to provide a way for it to delegate tasks to the other agents. So let's do that using some tools as well. So main agent.toPlane. And when creating a delegation tool, that runs other agents, we need to do it asynchronously because that's how the conversation loop happens internally in PydanticAI. So let's create an async def. Let's call it delegate to weather agent. And let's say it requires a location that's a string, returns a string. Let's also print to indicate that it's delegating to another agent and the location that it's passing. And here the result, we need to call await weather agent dot run, not run async, just run. What's the weather in, and then the location we received as a parameter. Then we can just return result dot data. Let's copy this tool and create another one to delegate to the math agent. So it will do pretty much the same thing, but it will require an expression and say delegating to math agent and just ask calculate and the expression. So let's also remove this result type from the main agent and let's also change the system prompt for it. So I just said you're a helpful assistant capable of delegating tasks to other agents if they're more specialized than you. So it will know to only delegate tasks if they're more specialized than itself. It should be smart enough to only delegate when that information that the other agent can provide is relevant to the query of the user. So now if we run our main agent again, we can ask math questions like what's the square root of 9? And then it will delegate to the math agent and fail because I forgot to remove the model dump JSON from the response. Since we're not formatting the response anymore, you can see here in the main agent, we removed the Pydantic model from the response. So now we just need to print result.data instead. Let's try this again. Okay, so what's the square root of 9? And it delegates to the math agent, passing this expression. And then the math agent replies with the response, and the main agent uses that response. So we can ask, what's the temperature in São Paulo now? And it will delegate to the weather agent, and then find the coordinates for São Paulo, and get the temperature, and return it to us. And also return a fun fact, because that's the way our weather agent replies. So our weather agent always replies in a specific format, but then our main agent will get that formatted response and use it to enhance its natural language response, right? So it responded here in a very conversational way. And it's smart enough to delegate to more than one agent and in the correct order if needed. So if you ask, is the current temperature in Tokyo times the speed of light a prime number? So it figured out the current temperature of Tokyo, and then our main agent was smart enough to orchestrate calling both agents, and then it compiled both of the responses and gave us the explanation for the calculation and also a fun fact for Tokyo. So this actually gives you a very good start with PydanticAI. It actually has some more complex abstractions like graphs. With graphs, you can define workflows pretty much, like really define the way that the execution flows through your agents. But this deserves its own video. And actually, this multi-agent scenario is already super powerful. For instance, we could have an email agent that has tools to list the latest emails and write emails. Then we can have a calendar agent that can list our Google Calendar events and create new ones. And then we can have a contacts agent that has access to a Google Sheet with all of our contacts. Then a main agent that can delegate to all of these other agents. And then if we ask something like create a meeting for tomorrow with John and send an email saying that it's to discuss the progress of our project, the main agent will be able to orchestrate all of this, or the main agent will be able to orchestrate all of the other agents to achieve this result. Yeah, so that pretty much covers everything I have for today. So thanks for watching the video and see you on the next one. Bye bye.